Great. Let's get started on our practice problems so that we can review from yesterday. You can write down whatever I write down here on your own paper so you can follow along. Number 1 says Mary is sitting next to Jane and they are 0.25 meters apart. We're going to draw a picture and label everything just so that you understand these types of problems. In 2.06, all the problems will have two objects, in this case Mary and Jane, and it'll always tell you how far apart they are. So the picture will always look like this, with two objects, both with mass, and it'll tell you how far apart they are, what is the distance, and we're just going to fill it in for this problem. Every problem will look exactly like this. The first object here is Mary. She is 60 kilograms. Second object is Jane over here, and she is 53 kilograms. And we can see that they are 0.25 meters apart. Now, we're ready to actually find the gravitational force between them. And what this is asking for is, because these two objects have mass, they will pull on each other gravitationally with a certain force. That's what we're trying to find. And the force of gravity is always equal to the equation big G times mass 1, mass 2 divided by distance squared. We're going to fill everything out together so that you're not confused anymore. The first mistake that students make in this type of problem is to not put in the big G. We are going to do that. I'm going to write big G up here so that you can remember what it is later on. It is equal to 6.67 times 10 to the negative 11. So that's our first term. We're going to write it in parentheses so everything is clear later on. Which one is which term? The second term is mass 1, and that is Mary's mass, 60. We need to type in mass 2, which is Jane's mass, that's 53 kilograms. And all divided by the distance squared, and that's 0.25. And here is the second mistake that students tend to make, not squaring it. So we're going to make sure we do that. And so now we're ready to type it into the calculator. And as long as we do it very, very deliberately, we are going to get it right. The first most confusing thing is probably entering the exponent, times 10 to the negative 11. Understand that even though it says times 10 to the, we don't need to type in times 10 at all. We just need to type in the exponent. So follow along as I punch it into the calculator. I'm going to put in parentheses 6.67. Instead of times 10 to the, I'm just going to type in second. And I'm going to find the exponent button, which is right above the 7. And you should see E on your calculator. Now we're ready to type in the exponent, which is negative 11. We have to press the negative down here, 11. Close parentheses. I'm just going to type in everything like I have on my paper now. Parentheses 60, parentheses 53, and then divided by, I'm going to put parentheses here just to be safe, 0.025 or 0.25. Close the parentheses and then square it. Squaring is right here. Remember to square it in the sentence as opposed to squaring it after you have pressed enter. Now we're ready to press enter. So the answer that we get is 0.00000. That's 50 followed by 3394. Make sure that you have this answer on your calculator as well before we move on. Great. This answer is not quite complete yet though, because it is missing a unit. Since the question is asking for gravitational force, I know that the units should be for force, which is newtons. And for these types of problem, any type of problem where it's asking for force, the units will always be newtons. Great. Moving on to number 2, we're going to write down the force of gravity because that's what it's asking for. It's asking for the gravitational force. Again, the equation is big G times mass 1, mass 2 divided by d squared. And so we're going to make sure that we always start with big G, which is the 6.67 times negative 10 to the negative 10. This time, however, for the first mass, it says that the Earth is 5.972 times 10 to the 24th power. So this is a weird number that we're going to see as opposed to the clean numbers in number 1, but that's okay. We're just going to plug it in anyways. Mass 2 is the moon's mass, which is 7.35 times 10 to the 22. That's 7.35 times 10 to the 22. Close parentheses divided by the distance, which is this big number right here, 384,400,000. That would be great if you stopped there, except you would have made a huge mistake of not squaring the distance. We have to make sure we're doing that. So we're now ready to punch it into the calculator. Again, every time you have an exponent, you don't have to type in times 10 to the, you simply have to type in e and then the exponent. So as always, we start with 6.67, second e, negative 11. Next term here is, so I open up a new parentheses, 5.972, again, second e, 24, which is the exponent. Close the parentheses for this term, open the next one, 7.35 times 10 to the negative, or times 10 to the 22. We're just going to type in again, second e 22, close the parentheses, and we can just continue to type it in. We're going to divide now by parentheses 384,000,000, close the parentheses, and press square. We're going to type everything in one single sentence. As long as you have done everything correctly, you should get the following answer. 1.985, we're going to round to 1.99, times 10 to the 22, again in newtons. Great. I hope you're getting the hang of it. Let's plow on to number 3. It says that 2 dust particles, and these questions are a little bit more difficult because you cannot find M1 and M2. You cannot find 2 masses. However, because it says there's 2 particles and it only gives you 1 mass, we're assuming that both particles have the exact same mass. So that means mass 1 is this, and also mass 2 is this, right? So again, we're going to start with Fg equals 2, and it is very, very tempting to just start typing in and writing down the first mass. However, we're not going to do that because we remember that we need to start with the big G before we put in M1, M2. So now we're ready to put in M1, which is this number, and also M2, which is the same number, and then divide it by the distance, which it tells us that the 2 particles are this far apart. So that is the distance times 10 to the negative 6. And if you stop there, you would just get the wrong answer. We don't want to get the wrong answer, so we're going to remember to square it. And so we're ready to plug it in. Again, we start with the 6.67, e, negative 11. close the parentheses so that we can start the next term, open another one, 7.53e negative 10, open another parentheses, 7.53e negative 10, divided by 1, open a parentheses, 1.2 e negative 6, close the parentheses, and make sure that you square it. You should get 2.63, we're going to round up, times 10 to the negative 17. And since it's asking for force, again, it is in newtons. I hope this makes everything more clear. Feel free to ask me any questions and raise your hand.